Hey guys, this is Vanessa. I want to talk to you a little bit about how we draw something called Bohr diagrams. They are diagrams that tell us about the electron configuration in an atom. And there are a few different topics I'm going to wrap into this. The first is how you draw them, the second is how you read them, and the third is a topic called valence electrons. So be sure to take notes as you go through this because you will need all of this info for upcoming assignments and quizzes. Um, so hopefully you did your last assignment, which was a bit about these electron configurations. This Bohr model is the model that looks a little bit like a solar system. It's not terribly accurate, but it does help us understand some things. So we use it to talk about electrons. So what we have in the middle of each of these diagrams, you see here is a circle with a P and an N. In the Bohr diagrams, we put the protons and neutrons. We write down the numbers in the middle, which represents the nucleus, right? So I want to take a look at how we then add in electrons and what kind of electrons we're going to add in. So in this model, the inner circle is the nucleus, okay? And all of the circles outside of that represent different energy levels where electrons kind of live, if you will. So let's start with helium. I drew what you'd find on the periodic table here for helium. Its symbol is He, its name is helium, its atomic number is 2, and then its atomic mass is 4.03. So this tells us a lot of information. The first thing is we know how many protons it has, right? Because that's its atomic number, number 2. It also tells us the number of neutrons that it has. We round this number to the nearest whole number, and that tells us how many neutrons we have. So what I'm going to do is I'm going to subtract, I'm going to round this to 4. It says 4.003, but just round it to 4. And subtract the number of protons, and that leaves you with the number of neutrons. Okay, so I have 2 protons, I have 2 neutrons, and I write those both here in the nucleus. And then I have to draw this. So I've got my proton and neutron information in the center, but now I have to draw my electrons. The rule is that if you have a neutral element or a neutral atom, which means it doesn't have a positive or negative charge, you'd have to have the same number of electrons as you have protons. So if you have 2 positive protons, you need 2 negative electrons to balance that out. All right. Now each of these rings, each of these orbits or levels can only hold so many electrons. So that's one of the most important things you have to learn. This first ring outside of the nucleus can only hold 2 electrons. And we draw that symbol just as a negative, all right, floating around on that circle. You can also draw it as like a circle with a negative sign inside of it. So we've got 2 electrons. Now this ring, this energy level, can only hold a maximum of 2 electrons. So we've maxed out this circle. We're going to go to a bigger atom to see what we do next. So head over here to sodium, okay, where we have 11 protons. It says we have 23 total atomic mass. So we take that 23 and we subtract 11 and we get 12. So we have 11 protons, 12 neutrons. We put that in the middle. But we know we have the same number of electrons as protons. So we know we have 11 electrons. We have to draw those in. Now we can only put 2 in this inner ring. So we've got 2 of our electrons here. Okay. And we still have 9 more to go. Now the interesting thing is that the next ring here can only hold 8. Okay, so we can put 8 more here. 1, 2, 3, 4, 5, 6, 7, 8, which gives us the 8 in this ring plus 9 and 10. But we actually need 11, so we're going to have to draw another ring around the outside, another energy level, and we'll put our 11th electron on that. Okay? So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Those are our 11 electrons. What you have to know about this is that you always have to fill in the inner rings first. So you always start inside. Okay? And then you have to work your way out. You have to fill up this inner ring, and then the second ring, and then the third. You can't just put them on any of the energy levels that you want. Okay, last but not least, we're going to do calcium. Calcium has 20 protons. It has a mass, an atomic mass of 40. So we do 40 minus 20, and that gives us 20 neutrons. So we have 20 protons, 20 neutrons. If we have 20 protons, then we also have 20 electrons. So we do our maximum of 2 on the inner energy level. We do our maximum of 8 on the second energy level. This third ring can also hold a maximum of 8. Okay, so we're going to put 8 there as well. So that brings us to 8 here, that's 16, 17, 18, but we need 20. So we actually need a 4th energy ring. Okay, do that here. And we have to put our last 2 electrons out here. But notice we filled in the first 3 rings first, okay? This is how you draw a Bohr diagram. It represents the electrons in an atom, and they get really big because you figure we have 118 elements, so we have as many as 118 protons and 118 neutrons. For now, we're going to focus on these smaller elements. But another thing you need to know is that the electrons that you find on the outer shell, okay, the outer ring, those are called valence electrons. All right, so valence electrons, V-A-L-E-N-C-E. Valence electrons are the electrons that are going to determine the behavior and the characteristics of an element, so they're really important. So you can see here, sodium, we only have, sorry guys, we only have 1 valence electron. Only 1 electron on the outer shell, okay? On this one, the outer, you only have 1 shell, so it's got 2 valence electrons, okay? And here on this outer shell, we also have 2 valence electrons. We're going to talk about more about what valence electrons do, but you want to know how to identify them for now. Okay, so make sure you understand these concepts, how we determine protons, neutrons, and electrons, how we diagram them, and then where we find valence electrons. All right, let me know if you guys have any questions, but otherwise, have a lovely day.